Going live on there we go. Hey, what's up, Hacksters? A bit of an early broadcast today. So on Monday, we did a mailbag show, and that was about all this cool stuff we've gotten in the mail. This is my first month as a member of the Boldport Club, which means that I get this beautiful PCB called the Monarch to put together. And we started soldering that together. You can see the video from Monday. I have linked that, the YouTube video from that, above this video or next to it or wherever you see that. I don't know, probably down there. But yeah, it's gorgeous. So far we've soldered on the sockets for the chips and the LEDs, and the LEDs can go on the top or the bottom. Most people are mounting them on the top, but I like the idea of the light shining through the PCB. As you can see, it's kind of translucent, and so I want to have that light from the LEDs shine up through the wings if possible. It's a really beautiful PCB, printed circuit board if you aren't familiar, and yeah, it brings this whole little circuit together. Boldport has a really signature style, to the point that he created his own PCB design app called PCB Mode or PCB Mod E that allows you to use Inkscape to create beautiful designed traces that are, you know, different from what you would get out of, say, Upverter or Eagle or KiCad, instead of being these sort of angular lines, which is an aesthetic that we love. You get these curvilinear, you can do whatever you want, but he uses these curvilinear lines. And we did an interview with him that's hopefully coming out next week. It's a lot of transcription. And in the meantime, I can share some things from it as a little preview. For example, here we have an example of something he talked about, which is that he really uses artistic license with these traces to make them look how he wants. It's an aesthetic thing as well as a functional thing. So for example, here you have a little loop in this trace in the circuit. And what the electricity is going to do is it's just going to flow directly from this pad to that leg, ignoring this loop completely, pretty much. I mean, there's some exceptions, like you mentioned, you know, he's gotten comments from people saying, you know, if you're doing radio and stuff, high frequency, then you're going to have problems with it, like noise and things like that. But we're not doing radio, we're just doing something with a shift register chip. And I'm going to talk about that in a second, too, before we get started with the soldering today. Or maybe after. We'll do it after. We want to get to the soldering. And yeah, so this is kind of an example of that, where he just does what looks pretty, and it really doesn't affect this circuit at all. All that's going to happen is that that's going to be kind of ignored. And yeah, you can see these little tiny butterflies included as copper traces underneath, or pores underneath the solder mask here. It's really a work of art. And so with no further ado, let me turn on my soldering iron and we will get started. So what we did already was the sockets for the chips and the LEDs. Besides that, I've got a bunch of resistors to throw on. I've got some capacitors, some little through-hole capacitors, little jelly bean ones, non-polar ceramic capacitors, a little switch, and a battery holder. And ooh, let me show you. I'm going to show you really quick the page for the Monarch. There we go. So you can look it up. It's at boldport.com/products/the-monarch. You can also find it in the menus up top. And it shows you, you know, how to assemble it and things like that. As you can see, people usually put the LEDs on top, and it's really gorgeous that way too. Just thought I'd try something new. And it uses resistors for legs. It's so brilliant. Look at that. I mean, they're mounted, you know, to the wings of the butterfly rather than to its body, but who cares? Like, it's all about making something beautiful. And here's the diagram I'm going to be following. We mentioned on Monday how this circuit uses a linear feedback shift register, which is a pseudo-random number generator. Or that's one of its popular applications, is for creating like close enough to random behavior for most of what you're going to want to do. It's not random enough for cryptography, because it can be, you can find the future states based on an initial seed value. So it is not predictable really, but you can work it out. So you would want a true hardware random number generator for like cryptographic and other like really secret applications. But in this case, yeah, it's combined with a chip. Let's see, this is the 273. That is, well, I'll go into that later. But this is a flip-flop circuit, so it saves states on or off. And then also the 74HC86 is a bunch of XOR gates, which are exclusive OR. It means that I said I wasn't going to do this, but okay. It basically means that if an so you have two inputs, right? And they can be high or low. And basically this means that if the two are the same, then you get a 0 or low output. And if they're different, then you get a 1 or high output. But we'll talk about that later. And there's also a 555 timer in here. It's just really cool. If you search for 555 timers on Hackster, there's a ton of cool example circuits and stuff that you can do. Okay, back to our circuit for now. Here we go. And I'm going to clean off my tip. So it's nice and shiny. Okay, and we're ready to go. All right, so what are we doing next? He recommends, at this point, we are going to prepare the resistors and the jumpers. To give you an example of where we are, we're down here. And again, like with the last kit, he recommends using the cutoff legs from the leftover from the resistors as some of these jumper wires, so that you have enough wire to create the antennae for the butterfly. It's all about like creative reuse and stuff. It's cool. Yeah, let's go back to this. So how are we setting up these resistors and jumpers? Well, there are little lines here. If you can see, there's dots, and those ones are going to be the jumpers, and then the blank ones are going to be our resistors. And there's a picture showing me which ones go where. So at the top we've got 5 holes, and that's 4 jumpers, and 1 resistor. That is our, what did we decide these are? Brown, black, orange. That's a 1, a 0, and 3 zeros, so that's a 10k ohm resistor. Yeah, we use one of those there. Let's just go ahead and slot that in. Gonna come in from the other side. And this is what determines how we get the tight connection to sort of hold the Monarch's wings up. Because you can see it started out as one PCB, and you sort of break and bend it to get this final shape. And your soldered components help hold it in place like that. Is this going to be tight enough? I think that's fine. It looks good. Okay. So I'm going to solder this on, and then I'll use those cutoff legs as a couple of the jumpers. Let's start putting in our other resistors first, though, so we can solder them all at once. Now the rest of them... Oh, right, all the ones that don't have dots. Cool. And the rest of them are all these other ones, and I've already forgotten what value, but it's a green, which is 5, blue, which is 6, and brown, which is 1, so 560 ohm resistors, if I'm not incorrect. Which I could be, who knows. We're using red LEDs, which implies to me that maybe that's a reasonable value. Because usually you'll go with like 100 or 330 ohm resistors for LEDs. And coming in from the other side, so that's the middle 4. Okay, cool. Go enter. There we go. Now he has a really cool sort of arched structure to these, which looks really nice, but I'm just going to do them flat across because I don't have those skills. Oh no, his are kind of flat too. That's fine. Okay. Aesthetics are important, right? That said, I've gotten comments before that I needed to orient all my resistors in the same way for aesthetics, and I don't really care. You can put them in either way. I guess it looks a little nicer if they all face the same way, but I've already broken that rule, so... as you know, resistors can be placed either way because they are nonpolar. They don't have an orientation. coming up for you later today, actually, more on the subject of sort of hacker businesses and kits and things. Sar talks a bit about the business of running a kit service and what it's like doing that, which is really fascinating, especially the aspects on pricing, and how, we talked a bit about how people are gonna sort of criticize you no matter how you price things, and especially with things that are more artistic, people kind of expect you to do it at cost, at the bare cost of the materials, and if you don't, then they're like, well, what are you doing? But that takes out respect for all your labor, and the fact that, in order to make yourself do something like that, which is an immense amount of work, you want to make sure that it's worthwhile for you and that it's sustainable. So watch out for that as part of the interview. Okay, time to solder these on. Oh yeah, so speaking of kits and things, right? We've got, I subscribed us to this one called Hacker Boxes. And I'm really curious, the first one has just come in. I'm curious, oh no, I knocked I got the socket a little bit. It doesn't make any difference, but speaking of aesthetics, yeah. So yeah, regarding kits and things, we got this first hacker box thing, and I'm really curious to see what's inside it. So we're gonna get that open on air. That'll be later today. And then hopefully the Boldport interview is gonna come out next Tuesday. We'll see. Otherwise, we will have a different interview for you for Hackster Cafe, our weekly Tuesday interview and news segment. That one was a little messy. Cool. Come off of there. So now we have a fresh crop of little silver leads that we can use to make the jumpers. I think I might have knocked the computer, but we're still pretty centered. Cool. Get out of there. All right, time for the jumpers. And let me double check that all these ones left have little dots by them. Yep. So all these ones left are our jumpers, and there's 6 of those. This could be a little challenging, but I think it'll be fine. I'm gonna curve it with my fingers. Oof. This might not be the most beautiful of monarchs out there. A couple of other people have already posted assembly videos, but I haven't watched any of them because I kind of didn't want to spoil the surprise. Ah, come here. We also talked a fair bit about failure and the relationship between makers and failure, and how you have to allow yourself to do so. And in fact, celebrate your failures. I wonder if I can just solder this from the top. That might be easier. It's still sort of getting all janked up. Oh well. It'll look nice no matter what. If you heat the circuit or the solder connection extra, sometimes you can get more of the solder to sort of flow through to the other side. Yeah, that's nice. Great. That's 1 jumper down, 5 to go. I'm gonna use little pliers to bend some of these. My favorite one is in the drawer underneath my computer here, so I'm not gonna get that. But I got some pliers on the ends of these wire strippers here. Cool. I can't wait to get this finished and look at the end result with y'all, because it's a really cool little PCB. And I'm going to use this guy to place it, if I can. Go in there. No, not in the other one. There we are. Ugh. It's not very smooth. It's got a little bend in it. Oh, well. It's fine. It's fine. I can always go back later with some pliers or something and really fine tune how these things are bent. You know, I almost wonder if staples would be a good option here. We don't have any, I think, but they should be plenty conductive. We don't use paper. We're a technological office. That's a lie. We use tons of paper. Ah! Come back. There we go. I've always had a fascination with working with really small things. When I was a kid, I was super into knots and stuff, and I think that's partly why I really enjoy electronics. It's because it's this very tactile sort of world in miniature. If you are into tiny electronics, you should totally check out Tiny Circuits, which is a company out of Akron, Ohio, and they make miniature Arduinos that are really easy to use. They stack together like Legos. They have one called the Tiny Lily that I love for wearable tech, which is washable as long as you remove the battery and stuff, you know. The controller itself can be washed, so it can just be sewn into your clothing. And there's other, you know, plenty of other ones like the Gemma and the Flora from Adafruit that are designed for the same thing, but I haven't really worked with those. And the Tiny Lily is the smallest of that sort of genre. So yeah, Tiny Circuits. They have a teeny tiny arcade that can sit on your desk and is about yay big. They also have a really tiny Game Boy that I saw at Maker Faire in New York. Oh, I haven't shared that video yet, have I? So much to do. Well, I'll put it on our Instagram or something, which is just instagram.com/Hackster.io. I'm plugging all the things. You gotta deal with it. I'm soldering here, and I would just be sort of like frowning and listening to whatever music of the day if I weren't like yammering on about this stuff. So if you wanted a quiet soldering session, just turn the sound off, huh? 2 more to go. Here we are. Again, I'm kind of cheating and soldering from the top and just like trying to get the solder to flow through to the other side. It's working pretty well. You can see how they have little domes on the bottom side as well. These are the ones I've just been doing. You can tell which are which because the resistors, I bent the legs outward and then clipped them. And then the ones that are just sort of straight through little domes are the ones I've just been doing. I'm gonna have to clip those off, clean them up a little bit too. One more. And I've managed to use resistors for all of these, the cutoff resistor leads, so we will have plenty of wire for the antennae in the end. This has a really cool control system where you squeeze the 2 antennae of the butterfly together. That's its control mechanism, and that causes the LEDs, they like turn on and off in sequence, and that allows you to advance the sequence. I don't pretend to fully understand this circuit yet, but I looked up the data sheets for the chips, and we're going to have a look at that after the fact. Oh, beautiful. Okay, this is becoming a little bit nicer. Cool. All right, I'm gonna clip off the leads from this, and what is our next step? Gently bend the boards to a desired angle. While keeping the angle, solder the resistors and wire jumpers. Then you solder the rest of the components using this image as a guide. Okay. It's a very small image, but that's kind of part of the point, is that there's a lot of experimentation. Oh, I like this image composition here with the red and black clippers and the... Yeah, anyway. It's an artistic day, huh? That's what happens when you get me in the morning. And bend these out a little bit. Try and curve them. Yeah, it's not too bad. I think these two are the main, like the first couple that I did were the least aesthetically pleasing. Close enough. Okay, look at that. Pretty little bridges. And we've got the wings flexed. And the LEDs on the bottom. Cool. Okay, rest of the components go on the bottom. That's a couple of capacitors, which I guess I'll do first. Then a ton of resistors. There's actually 3 spots for capacitors, but you only get 2, and the picture only shows 2, so I'm not going to freak out about that. They both have the same value on them, which is 105. And do I want to cut these a little shorter? I probably do. Yeah. Unless they... No, they're too long. Okay. You're getting cut down, boy. I don't know where that came from. Okay. Let's put some solder on these pads here. Ooh. Don't take it personally if I hit the computer. So you can see that the 555 timer goes up top here, and it's connected to these two, which are going to be 10k ohm resistors. And then the rest are going to be these 560? Is that what we decided they were? Yeah. And those go to the other chips. So that's kind of interesting. I guess they go... oh, so the 555 goes through the resistors to the capacitor, which goes to the LED. Huh. That may have not made sense to anyone except me inside my head. Don't worry about it. Let's see if I can do this in a responsible way. Note that my thumb is not touching the leads. Ooh, 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 ooh. Stay. There we go. Cool. There we are. Can I get this a little better? I think that's about what we're gonna get. That's not bad. A little ugly, but not bad. And the other one. I'm certain that there are better ways to do this, but I'm not doing it those ways, so... Actually, maybe I will. I'm gonna use my wire strippers this time as pliers again, and see if I can get this to, No, because it's gotta be the other way. Maybe use the clippers. Ugh! as you are assembling your Monarch, if you have one, don't be afraid of failure, she says when it is extremely relevant. Because if you do make an honest effort and you share your work and stuff, he'll just send you another kit. I mean, you know, don't abuse it, obviously, but that is word from the man Sar himself. It's all about allowing yourself to try and possibly fail. Okay, cool. We're in business now. Oh, it's so much more beautiful. Yeah, there we go. That's what I was after. Let's try and get a little bit... Ugh, so messy. But it'll work. Cool. Okay, that wasn't so bad. Now we've got a ton of resistors to put on there. Ooh, you know what? Well, I'm just looking at this, and I feel like maybe one reason to put the LEDs on the other side is in case you're like a little worried about getting your soldering skills in there with the switch, but I think it's going to be pretty easy, so it'll be fine. I'm going to do the two boring resistors first. The rest we have 2, 4, 6, 8, 10, 12, 14. 14? Oh yeah, there's a set of the 560s over here, and the rest of them turn into the legs. I haven't actually soldered LEDs or resistors in this configuration before, like a sort of bridge between two surface mount contacts. That's going to be interesting. Hope I make these leads long enough, otherwise I'm in trouble. Yeah, okay, cool. I'm going to bend them a little bit so that they'll contact the pads. Like so. It'll work. I'm going to tin these pads. And then use my clippers as pliers again. You can use tweezers, pliers, whatever you want. This is going to be a little gross, but it'll be fine. Oh no! Come back! Ah! There we are. Obviously I'm keeping a pretty light touch on the clippers here because I don't want to actually damage the resistor. There's not a huge risk of that. Okie doke. How do regular people do this? I have no idea. Maybe it's something he made up. Because I've never seen, yeah, resistors in a kit applied like this. It makes sense, you know, that way you don't have leads sticking out the other side. It's a little tricky. And mine is not going to be as pretty as the example, but that's fine. I probably should have done the inner one first. That would probably make it easier for me to put this together now. The second one. Let's get a good angle on here. Alright. And if I wanted to make this easier on myself, what I could have done is tinned the resistors first as well, but I didn't. Alright, that's pretty solid. 2 more in this weird configuration. And again, I am just cutting and bending the leads into position beforehand. It's not that exciting, you're not missing much. I'm using my strippers as pliers here. It's so tiny. I used to do art with twisted wire, and you would think I would be better at this. Maybe if I hadn't done that, I'd be way worse, so, you know. Okay, tinning the pads. This would be easier without the LEDs there. If I had done the LEDs after the fact, that might have made this easier. But I'm strictly following the tutorial, and so that sort of shows, you know, you shouldn't always follow tutorials exactly, so. Ah! Use your own judgment. I'm gonna do the other one at the same time, I think. Ah! Knew that would happen eventually. There's only so much grip that you can get on a slippery resistor with a sharp edge. Yeah, I'm really interested in this whole kit ecosystem. There's a ton of them out there. We have talked about Tron Club, Adafruits, Adabox, a couple of others. But Tron Club and the Adabox are the two that we've specifically done tutorials with and reviewed on here. Tron Club is great. It's this Canadian company, and they send you 22 circuits that you can build with the included components each month, with like a little booklet that includes tips about the components and background and cool stuff. I really hope they're still running, because that was a year or two ago when I first started doing video. But you can find that on our YouTube channel, which is youtube.com/Hackster.io, just like all of our other things. Facebook, Instagram, Twitter, YouTube, it's all the same. And it's not pronounced Hackstereo. Okay, cool. What's next? We're gonna, I think I'll put the battery and the switch on and then do all these legs, because otherwise they'll be in the way. So the battery comes in, no, I'll do the switch first. That's the inner component. Here we are, and it doesn't matter which way I assemble this, because it's a switch, so these two legs are connected when the switch is over here, and the two over here are connected when the switch is over here. So yeah, you can either switch between two modes or on and off or whatever. It's in the pads. I'm just going to quickly tack solder one on. And try to kind of use that to move it into position. That looks pretty good. It could be angled a little better. Oh, you're not going to move, are you? No, you're going to make me completely remelt it. This can be tough because, like, you know, there's already a dome of solder on each of the legs. So it's hard to position it. That's close enough. Pretty. All right, switch is on. All the connections look solid. So we're going to do the battery now. And then we will do the rest of the resistors, which are part of what makes this PCB so beautiful. As you can see, the battery holder has, well, the positive side of the battery coin cell is going to go up, and it's got a slot on one side that you can slide the battery in. That obviously has to be outside. So I'm going to tin these two big pads. I love how they kind of look hand-drawn, which they probably were. Or drawn like with a cursor in Inkscape or something. The other pad on here does not get any solder. That's just the contact for the negative or ground side of the battery. You know, this is going to get really hot, so I'm going to hold it. Maybe I'll hold that with the third hand. Whoa! Getting fancy. Put down the soldering iron when your hands are full. Can we do it? We can kind of do it. It's not very good. What about this? That's not great either, but oh no, it's really not great. I'll just hold it like this. There we go. Perfect. I'm gonna fix the focus for you a little bit. Beautiful. A beautiful PCB deserves a beautiful focus. Soldering to battery holders is always a little weird because they're basically huge heat sinks. It wants to pull all the heat away from your connection and into the rest of it. It's not the best position. Let's remelt this and see if we can get it a little bit. Oh, no! There we go. It's not actually that hot when I'm touching it. Okay. Now the other one is going to be easier, because the other one's holding it in place. All right. Come on. Let's add a little bit more solder on here. There we go. That's nice. Ow. I always grab it with my fingers. I always do. But, no, yeah, I'm going to heat that up a little bit more. And make sure there's a good, there we are. Nice, pretty solid contact. Before the metal was lifted up a little bit, and so you really had this hole in it. That looks pretty good. All right, time for the rest of the resistors, and then we will insert the chips, and then we will, yeah, give it a go. Oh, we've got to do the antenna too. Do I do that now or later? Let's see. Oh, now. Cool. So we've got this wire here. Doop, doop, doop. That's for creating the antennae. And I really don't even need that much of it. So I'm just gonna cut off like yay much and then cut it in half. I could give it like a really pretty big antennae though. I'll do that. Alright. One thing I did learn was how to like straighten out wire. You just sort of like curve it back and forth between your fingers, and it gets rid of all the little kinks and stuff. Because you really want it to be a sort of smooth arc. Cool, and this is not solder wire, even though it looks like the same thickness as solder. It is definitely not. It's a little bit more resistant. It curves back a little bit more. And also, it's not going to poison me. Okay. These are about the same length now. I'm going to curve them around to make little curly antennae. Oh! I'm going to drop them first. It's an essential part of the process. Ooh, so pretty. Part 1. And is there anything special I need to do to attach this? No, not really. Cool. And part 2. Trying to make these match. How's that? Come here. Got stuck in the little jumpers and resistors and stuff. Ah, that's a pretty solid match. Cool. And then we're gonna stick them in here. Curling up. So I'm gonna stick this through and then pull it down so that it kind of sits in there on its own. Do the same thing. Stick it through and pull it down. And push the other one out of the way. There we go. Oh, I put one in further than the other one. We'll just do that. Cool. And then after the fact, we can sort of pose these a little more. I'm gonna do the same thing that I did with the jumpers and solder these from the top down. Angle it this way so that that one goes in at the right angle via gravity. And then we're gonna turn it that way so that the other one wants to fall down the other way. Ah! Positioning. Okay, cool. It's so pretty. How does that look on the other side? Ah, pretty solid. We've got little solder cones. Beautiful. Gonna cut off the extra. Doesn't really matter though. I'll just leave it. Aesthetic license. In order to make this go, I'm gonna have to squeeze these together. And it's possible that if I have them this far apart, then after a while they're going to fatigue and break. But that's fine. I mean, wire is not exactly a low supply tool material thing. Okay, let's do the cool resistor legs. I love this part of it because it is a really, really ingenious way. So these are 560 ohm resistors, right? And what we're going to do is connect them in series, which means we're going to add their values to create one bigger resistor. And the way that we do that is by soldering them on here to these pads, and then soldering them together at the other end. So that basically from this pad to that pad is twice the value of a 560 ohm resistor, which is what, 1120? Yeah. So it's going to be the equivalent of one 1120 ohm resistor, but made with two 560s, which is pretty cool. I think I'm going to first solder the other two ends together and then solder them to the PCB. So I'm going to make 6 pairs of these. Let's zoom out a little so we can have, there we go, a good view. Or actually, I'm going to use the third hand. Can I get them both in there solidly? Yeah. I want to line them up. Ugh. Holding on too hard. Grrr. Well, one of them is a little loose, but that's okay. Actually, let's stick this one in over here, closer to the end, and then I'll just make sure that they overlap like this. Might have to hold that one. That's fine. Let's put a glob on here first. And then attach the other one. Ooh, I'll put a glob on the other one too. And that way they will merge to form one mega glob. Hopefully. Ah! Okay. By the time we do the number 6 one, we're going to have a wonderful methodology worked out for this. Oh god, the third hand is running away. Well, I can always fix it after the fact. Okay. Pair number 1 is done. Of course I put them in opposite configurations. Oh, I'm going to flip it around. I have to. At least the pairs of legs should be like coordinated, right? So I'm going to do that now. Which means I need a little bit more solder. Got a bunch of gunk on my iron here. And I'm just going to sort of put this, I'm going to try putting the solder here in the middle and sort of pulling the pair onto it. But I'm going to hold these far, far away. And then we'll fix the bending in the resistors afterwards. Still more gunk. There we go. Cool. That's pretty solid. Alright, so that's one pair down. I'm grabbing the other ones off of this tape. You can either cut components off of tape, or in the case of resistors, they're pretty easy to just pull out. And I decided that the green ends should be connected together. So let's set that up. There we go. Two pairs down. We got 4 more of these to do. This is a really long project. I mean, compared to the soldering stuff that we usually do, it's not actually that long. But in terms of a continuous live stream, it's a little crazy. All right. I really hope you guys are enjoying this, because I'm really enjoying putting it together. It's such a sort of tactile thing to do on a Thursday or Wednesday morning. What day even is it? Okay. Trying to hold these steady. There we go. I'm heating up the leads with the soldering iron and only touching it with the solder at the end so that it actually connects the two together and doesn't just sort of glob onto the iron. Let's try that one more time. I want some more on there. Oh no, I took them apart. There we go. Now we've got a pretty good bead. I think that's a little more aesthetically pleasing. 3 more pairs to go. So each pair is going to become one leg, and those support the PCB in the end. It sort of stands on those. And that's partly why I put the LEDs on the bottom, is because I really love the look of underlighting. So even if it doesn't shine through the PCB itself, the LED light is going to shine on the table, and that'll look really cool. Yeah, when it comes to like LED lights, I'm a huge fan of indirect lighting, just because like a direct view can be kind of harsh. In the case of something like this, where you're kind of showing off the mathematical, like, this one is on, and that one is on, and this one is on, you know, it might make more sense to have them on top so you can clearly see which exact ones are on. But, you know, you can always flip it over, pick it up and flip it over, and that's what it's made for, right? Is for like having it sit on your desk and playing around with it when you're bored, when you're on the phone, just pushing the little button, you know? I do that all the time. Okay. Second to last one here. Oh, stop twisting. If I were tilting this downwards more, I'd get more of a glob on the end because of gravity, but it's fine. Final pair. Let's go. And then there's actually one other thing that we have to do besides inserting the chips, and that is connecting. There's one XOR gate apparently that is left unconnected, and apparently it will work with that unconnected, but you want to connect it with a jumper. However, it's left sort of up to you in case you want to play around with other ways of doing it. There we go, that's a nice glob. Okay. So, here we are. And each of these pairs has got to be connected to a set of little connections on the PCB. Here we go. I'm going to do the left ones first, because that'll be a little easier to do from that side. Okay. I'm going to bend these down a little bit so that they're parallel and they can get around the LED here. And then the other thing that I'm going to do is tin the pads. We're getting crowded in here now. Ah! Go on there. Cool. And you know, the instructions don't give you any particular order in which to solder on these components. Oh no, I'm gonna get a short here if I don't be careful. Okay, I'm gonna do a little bit of extra clipping in here after the fact. Okay, so there's a little bit. Oh! Soldering info. Danger, danger. Pardon the technical difficulties. Okay, this is our wake-up call. Where were we? Oh yeah, so if you can see, there is an issue here where the leads are very close together. And so I'm just gonna give those an extra little, oh! Microphone fell too, and it lost its little clip, oh no! Surely we have a way to fix this. We have alligator clips. This'll do. Okay. Close enough. How's that? Okay, cool. So, what are we doing? Yeah, we're clipping these things in case they short out. It does smell a little bit like burning. Oh, it's just a crappy bag I had. Alright. Without further ado, let us clip these down. And that looks pretty fine. They're not gonna touch. Okay, cool. Next pair. If it's any excuse, I was at the Chinese consulate today at 9 a.m. and I've already been through a fair amount. So forgive my slight clumsiness. But that is some pretty exciting news. I got a visa for a particular trip that is going to happen soon. I can't wait to tell you about it. Let's do one first. And then stick the other on. And I'm just gonna do sort of a bad practice and apply a little extra solder directly from the iron. There we go. That looks pretty good. And we didn't pull the soldering iron off the table again. What happened there anyway? I think my mic cable like caught on the iron wire or something. Hazards of the profession, I guess. Okay, we got 4 more of these to go. I mean, it's true though, there's all kinds of stuff that can happen in a workshop and you never know what exactly it's going to be. Could be, you know, lead fumes. You want to make sure that you're dealing with your solder fumes very well. I usually have a window open right here. You want to wash your hands after you solder. Make sure that you are holding the iron correctly and that you give yourself plenty of solder to work with so that your fingers aren't all up in the joint. Try not to burn yourself. Be careful with hot glue. It's always hot glue that I burn myself on. Which is kind of pathetic. Like, I should have kind of gotten past that in 5th grade, but I guess I was not a very good Girl Scout or something. That's true, I was not a very good Girl Scout. There we go. 3 more. We're going to flip this around. And then we're going to bend them into position. This is that jumper that we were talking about, the XOR connection. Yeah. Because this chip is a bunch of XOR gates, exclusive OR gates, and this one is flip-flops. I have that backwards. No, because you said that it's an XOR gate that's left unconnected. Yeah, and then this one is a 555, which is a 555 timer chip. Those are really popular for things like, you know, creating little synthesizers, making LED effects that blink or that chase each other and stuff like that. Yeah, the 555 is a great little chip. And it's fun to look at how those things work in a more in-depth fashion. So I recently, you know, last month was Inktober. All your artist friends were posting an ink drawing per day. And I tried to get in on it, but I only ever made about $5 drawings total. But they were really fun to do. And one of the things I did was a visualization of the innards of a 555 timer, but in the shape of a beetle. And it's really cool to do that kind of project because it's aesthetically gratifying, but at the same time, you're sort of learning stuff. And so I hope to do some more and kind of share them as we go. Come here. There we go. Two more. I could probably give it a little shorter of a bend. Huh. Oh well. And one more. Oh no, these are kind of bent in opposing directions. No good. Come on. That's close enough. Cool. All right, we've got the legs on. I want to show this to you at a little bit more distance, which means changing our focus again. There we go. Yeah, awesome. I'm going to bend these in artistic fashion. So sort of down and then curving out. This kind of a shape, an S. And again over here. And once I actually set this on the table, it's going to be a lot easier to see how this should go. Okay. Looks like some of the legs are still kind of hovering. Ah! Mine goes face first into the ground. Okay, that means we need to make the front legs come down further. Doop, doop, doop. And the back legs come down less far. We can also move the back ones further back. There we go. Oh, that's gorgeous. Now we've got that one XOR connection to make. Oh, this is a great way to start the day, let me tell you. Okay. We left one XOR gate's inputs floating. Let me show you what I'm looking at. Unconnected, so that it could be used by you to try different LFSR, that's linear feedback shift register? Yeah. Arrangements. Leaving inputs floating is a bad practice since it could lead to higher power consumption, in the order of milliamps in this case, under some conditions. So even if the circuit will work without, we strongly recommend using a short wire to connect the XOR's inputs to ground as shown. Okay, cool. I guess I'm supposed to connect them both? Yeah. And let's see. Oh, I see. Okay. So that's going to be this guy, and then ground. Let me double check that. Yeah. So what's this then? Does it connect to ground on the other side? It must. Let's find another ground. Because usually there's a whole big pour that's a ground plane that makes it easy to connect stuff to it. But I'm not sure if that's the case over here. Oh wait, let's see. So we've got the short side of the LED. The ground side over here connects to this wire. So that must be a ground pin. And, you know, it's really hard to tell if that actually connects or not. Well, I can see that there's a... this is really fun looking at PCBs like this. Up close. Extreme close-up. So here is the positive side of the LED. And you can see that there's a break in the pour there. So there's a, between where the solder pad is and where that light area on the red is, which is where the copper is, there's a break, which means that they're not connected. So my assumption is that this is ground over here. This maybe is a whole big ground pour. Or maybe it's not connected to anything, I don't know. Oh, because this ground one isn't connected either. Maybe it's just for aesthetics. It's really hard to tell with SAR. Cool. But anyway, what we're going to do is hook up these two dots here to that ground pin. And there's a number of different ways that we could do this. So what I am going to do is I think use one little wire and kind of curve it around to both. And I've got a fair amount of this wire left over from the antennae, so I'm going to kind of bend it a little bit over to the side, like so. A little bit left of center, and then I'm going to curve them both into a kind of frond shape. You'll see what I mean in a second. And this is just because I'm lazy and I don't want to solder multiple wires to this. So I'm just doing one that will hopefully reach both. Let's see, maybe a little closer together. And this is where that wire modeling experience comes in. Okay, I think this should work. Let's have a look. Again, everything is really tightly packed at this point, so it's going to be a little challenging. But if I come in here with this, can I get them both connected? Oh, way too wide of an angle. Whoa! I'm dropping it. Okay, how about this? Oh, that works pretty well. Cool. So I'm going to solder it to the ground pin first, and then make big blobs to connect it to the other pads on there. And I'm going to also curve these a little bit more so that they really will touch down. Okay. Is that good? That's pretty good. I also need to make sure that I'm not shorting anything else. So let's come in here. I'm going to tin the middle part and the ends of this wire, which may end up with just, solder all over the whole thing, but we'll see. No, it worked pretty well. This wire is thick enough that heat doesn't propagate down it as quickly, which means that I was able to make 3 separate areas of solder on here. Ah! Oh yeah, I'm going to tin the pads too. Put a little extra on here. Cool. Now let's come in here. Again, what are they called? Tweezers would probably be the optimal thing here, but I don't have any on me, so we're just going to use the side cutters. Okay, that is connected. Now I'm going to give this a little squeeze to make sure that it sort of makes a good connection to here. It's a little bit off. Maybe I'll connect the other one first to make sure it's anchored really well, because physical connections are important too. Beautiful. Cool. And let's get this all in place. It's a pretty rigid wire, so I really need to make sure that it's well anchored before I start bending it. I don't want to put stress on anything else. Cool. And finally, we solder this guy. Cool. And now before I hook up the whole thing to the battery, I'm going to double check that I actually connected the right things just then. It looks really solid. I actually really like how that came out. Yeah. And so he shows a different way of doing this actually, a different configuration of the wire. What you'll see here. So he shows a little sort of zigzag to the left and then to the right. And what I did is take the ground wire and just branch it out to both of them. And it's the same thing because they're both getting connected to ground either way. So it doesn't really matter. But yeah, you have this solid little bridge connection. It's really cute, if I do say so myself. Okay, let's stick the chips in. And hopefully I've done this the right way, and we won't have terrible butterfly dying times. But if we do, then it'll be okay. Focus a little bit further away. So when you're putting chips in sockets, often the way that they'll come is with their legs split a little bit apart because they come on this rail. And so in order to put them in the actual socket, you gotta kind of take it against the table and bend those legs inward a little bit so that they're more straight down. And I use the table so that all the legs end up sort of parallel, you know? And see, that's a little bit more, oh, we can compare it with the other one. If you see, now this one are facing more straight down and these are still pointed out. And then again, like we said in the first video, you've got to pay attention to where pin 1 is for the correct orientation of the chip. On this chip, it is indicated by a divot over there on the left side. And so what I'm going to do is orient that along with the divot in the socket itself. Notice that only one end of the socket has a little divot like this. Let's not lose any chips. And so you go in there. Oh yes. Still a little wide, in fact. Come on. Come on, dude. Go in there. Alright. We can kind of push it in. There we are. Very nice. So that's the first one. And that is our, which one is that? This one is an 73C3N3KE4. Oh, that's not actually the chip number though. So what we've got down here at the bottom is that it says SN74HC273N. And we're gonna, let's take a look at the data sheet for that real quick. That's the first one I've got pulled up here. So, what have we got? It is an octal D-type flip-flop with clear, whatever that means. Oh, right. So it's a flip-flop, so it stores states, right, as ones or zeros, because this circuit can flip or flop back and forth between being high or low, you know, 1 or 0. And so the clear function must be to clear all stored states. So it probably restores everything to a 0. Cool. Yeah, here's its logic diagram. That's pretty cool. Come back. Come back. There we are. I really like logic diagrams. I think they look super cool. So that's our first big chip on here. The next one we have, let's put it in. I'm going to have to bend this again. I'm usually a little bit shy about this, so I've got to be a bit more aggressive. Make sure they actually will go in there. Okay, let's see. This time we have the pin 1 marker is over at the top, and then this side is blank. So I'm going to put pin 1, again that's a divot on this chip, aligned that way. And that is much easier this time. Go in there. Beautiful. And there are specially designed tools for pulling chips out of their sockets, but we're not going to do that for a while, I hope. Then the final one is your 555. It's an 8-pin. Oh, what is this one? Let's have a look. It is a SN74HC85N. I've pulled up that datasheet as well. Oh yeah, flip-flops. You can check out the Wikipedia page for that one, for the first chip. It's really fascinating. They're built with, like, here's a little bridge with some resistors and a couple of transistors. The 2 transistors are sort of the key element in a flip-flop. Yeah, it's cool. And more logic gates over here. This second chip, yes. Quadruple 2-input exclusive OR gates. So as I mentioned before, an exclusive OR gate means that it signals high or a 1 as long as either one of the inputs is high, but not if both are. So if the 2 are the same, then it's a false output. I should say false, yeah. And otherwise it's true. High, low, 1, 0, true, false. These are all sort of compatible terms for the similar idea. And here you see there's different versions of this chip and different packages, and they have different capacities and attributes. Yeah, so here it shows them as high and low. That's L and H, or low and high, you know what I mean. This is the symbol for an XOR chip, or gate. Yeah. And then on the Wikipedia page, they show the truth table. That is, the way that you show what the result will be from a logic gate. They show it as 1s and 0s over on the right there, which is kind of hard to see. What if I just... Nope. Dragging the wrong window. There we go. Yeah. So here, they're using 1s and 0s. So 0s for low, or false, and 1s for high or true. So, all these are sort of the same thing. So yeah, this chip contains 4 of them? Yeah, quadruple. So that's kind of cool. And how many things does it have? It's got 14 pins. So some of them are going to be voltage, some of them are going to be ground. And then you've got the pins for the XOR. So it looks like one of the gates has 2 inputs, which makes sense because it's comparing the 2, right? It's comparing to see if you have 2 0s, 2 1s, or 1 of each. And so we're connecting both of those inputs to ground. That's what we just did with that jumper. Okay, now time for the 555, and then it's almost Blinky time. Guys, I'm so excited. We've been trying to finish this one since Monday. Construction is exciting, but it also, can be a little disruptive. It also means that my poor coworkers have to hear every inane line and terrible joke that I say during this broadcast, which is kind of great. Okay, so the 555 has its little pin 1 indicator over to the left there, the divot. And this one has a different indicator. On the chip itself, it has a little dot to show which one is pin 1, and that's very common with these little 8-pin chips. There's your 555. There's a number of different companies that make these, actually. This one is by TI. Texas Instruments. Same people who made my TI-83 Plus calculator in high school. Okay, cool. Moment of truth. It doesn't say which way the switch is on or off, so let's see. There's a connection. Huh. Okay. There's a connection to this far right pin, or yeah, over here. And then there's one that's coming out the end there, and that's got to be connected to one of the middle pins. So currently it's in the on position. I'm going to switch it off so we have a really good reveal moment. Now, where the heck is a battery we can use with this thing? Here we go. Hopefully it's one that still works. Otherwise I'll have to go grab another. Go in there. Yes! Oh, cool! Let's get a little bit better focus on this. Oh, this is so exciting. Oh, gorgeous. So we've got a few of these LEDs on. I'm going to turn down my lights so you can see a little better. All right, yeah. Wow, gorgeous. Maybe I can even bring down the brightness a bit. So yeah, that's really clear. Oh, check that out. 3 LEDs on. And then if we touch these antennae together, it changes. Like a butterfly flapping its wings. Super cool. And then if we look at it from above, oh, that's really cool. Oh, look at that. Not only does it shine through the PCB a little bit, which looks really rad. But also you get these little spots of light on the table too. I really dig this. Oh man, I sound like a complete idiot, but I don't care. It's gorgeous. Yeah, look at that. This is a really ethereal and kind of beautiful PCB. I love how it sort of sits on its little legs. I'm going to turn my soldering iron off so we can't do any more damage with that. And sort of clean off the wire shavings here so we don't get any random shorts we're not supposed to have. And yeah, look at this. Let me squeeze the antennae together. And you get this really beautiful sort of fluttering effect with the light coming through. Oh, that's just gorgeous. So yeah, no lie, I joined the club this month because Sarah posted this tweet that was like, okay, this is your last day to join the club and get the Monarch. And you know, I couldn't not. This is so cool. You gotta see what this is doing on the table too. It's like this little disco effect. I'm creating kind of a halo around the butterfly itself. Well, this is a great payoff after a couple hours of soldering. I hope you feel the same way too. And I'm gonna put part 2 of this up on YouTube, where you can find part 1, the first installment. And yeah, the link to this kit is gonna be underneath this video. Have an awesome, what is it, Wednesday? Yeah, it's definitely what the Wednesday today. I hope you enjoy seeing this and just sharing a bit of beautiful PCB art and soldering on this morning. If you put one together, I'd love to see. Share your pictures of your final product. Let us know whether you decided to put the LEDs on the top or the bottom, and how you chose to bridge that XOR gate, which comes down to your own choice. And if you had any struggles, especially like anything you struggled with, would love to see that. Yeah, so happy. Thanks for watching and have a great Wednesday.